We're going to look at one reaction of hydrocarbons, and in particular here, combustion. The hydrocarbon we're going to look at is methane, and it's an alkane, so a member of a homologous series, and they all end in ANE, family of organic chemicals, and the alkanes are saturated, which means they have the maximum number of hydrogen atoms for each carbon atom present, and single carbon-carbon bonds if there's more than one carbon atom. And the general formula of CnH2n plus 2. So the formula and the equation for the combustion of methane in plenty of oxygen yields carbon dioxide gas, and because of the temperature, water is a vapor. And the gas that comes out of the gas taps and lights the Bunsen burners is methane. And here you're looking with a Bunsen burner with the hole wide open, and you get a blue flame. And you are completely combusting the methane and getting carbon dioxide and water vapor. So the flame, when you look at it, has a bluish color but is almost transparent. It has a definite shape and is noisy. You can actually hear the burn if everything else is fairly quiet. And it's the hottest of the flames that you can get with a Bunsen burner, and the one that you will use most frequently when you're heating chemicals in the lab. So if you close the air hole at the bottom of the chimney, the flame becomes yellow. It doesn't have any definite shape, and it's pretty silent. But what you're seeing with the yellow flame is carbon that is glowing in the heat. But if you hold some cool apparatus there, bottom of a test tube, hold it in test tube holders, you'll see soot formed. And so the equation here, you can see the carbon that is formed. And we're going to see what happens when a larger amount of methane is ignited, and we're going to use a gas jar. And so just a long, tall jar, a tall form beaker would work as well. So the gas jar's filled with water, lid put over it to invert it so that it opens then in a trough with water in it, and have just rubber tubing joined to the gas tap. But it's best not to put the tubing straight under the gas jar, because remember, there will be air in the rubber tubing, so just let that escape into the air before you collect the gas. And here you can see bubbles of methane rising because the gas is lighter than water. And it's called filling the gas jar with the gas by downward displacement of water. So when the gas jar is full, put your hand into the water and put a gas jar lid over the bottom of it, obviously having turned off the gas and removed the tubing. And then with the lid in place, put it upright on the bench, and then bring up a firelighter, and as you light the firelighter, remove the gas jar lid and place it in the mouth of the gas jar. So we're going to watch a slow motion video. Thank you, Daniel, who took this video. But while you're looking at it, describe its color, how high it is, how it burns. You can compare it to the Bunsen flames, how long this particular burning takes place, but slightly difficult because it's slow motion. And look very carefully. What else do you see? to just review the burning of methane. The equation again, this is showing the complete combustion, but any yellowness that is there is because there isn't quite enough oxygen and you get carbon glowing in the heat. So you're going to form carbon dioxide and water vapor. If you looked carefully, you would have seen condensation on the gas jar. The water vapor on the cooler glass condenses, and any yellowness in the flame will be the carbon glowing. Burns down from the top, so you have a flame front that is moving down the gas jar. And we could test the condensation with blue cobalt chloride paper, which goes red in the presence of water, moisture, and forms the anhydrous cobalt chloride forms the hydrated cobalt chloride. Could also test for carbon dioxide when the product of the gas, put the lid back on, put in some lime water, shake it, and it will go milky. And here is the equation, and the milkiness is due to the solid insoluble calcium carbonate that is formed. So really tiny particles of chalk. And thank you very much to Washington International School for use of your labs.